Okay, we're going to look at trigonometric ratios. Sometimes they're called primary trig ratios. They have lots of different names. And these ratios are set up to help us solve right angle triangles. So the triangles, when we use these, must be right angle. And these are them. Sine theta, and this stands for the angle, the measure of that angle. Okay? So every time I say theta, you have to remember that this is some angle within the triangle. Okay? So sine theta is equal to the opposite side of the triangle divided by, that's what that means, the hypotenuse. Cos theta, so cos of that angle, is equal to the adjacent side of the triangle divided by the hypotenuse. And tan theta is equal to the opposite side of that triangle divided by the adjacent. So each of these have a different side of a triangle. They use a acronym called SOHCAHTOA. Okay, and the reason they do that is so it helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this acronym SOHCAHTOA is supposed to help us remember what we're doing here. So let's talk about right angle triangles. So I got a whole list of them here, and I'm going to give us some numbers. So I've chosen these numbers. Let's just assume that this triangle was created, and this side happened to be 3, this side happened to be 4, and this side happened to be 5. Okay, we're going to build on, or at least in this version, we're going to build all of our sine ratios here. Okay, all of our cosine ratio here, and all of our tangents under here. Okay, now whenever we do these, okay, there's really only 2 angles in the triangle we measure from, and I guess I'll write the other sides in as we're talking about this. But the right angle here, we don't use SOHCAHTOA for it. That would never be the angle in the formula. We're never talking about this theta. This would never be our, so I'll put 90 and cross it out. Whoops. 9. Okay, 9 there. It does it all the time. Whatever it is, 90 degrees, we don't use it in this spot, okay? So let's keep that in mind. Really, that means is we're either looking at this angle or this angle. There's only 2 to really talk about, okay? So we're going to stop at our at our top angle, and I'm going to call this theta. So that's the angle we're talking about, okay? And maybe I shouldn't do it in red because we really want to color code this. I'm going to do it in purple here, just so that we have some good color coding for our note. Okay, so if this is the case and I want to find sine, well, sine theta is equal to the opposite. So which side is opposite of that theta? Which side of the triangle? Yeah, that's right, the 3. Perfect point. This would be the opposite side, so I'm just going to go op. Okay, so that's opposite.
Your theta would be A in this situation.
Yeah, exactly. They use the letter A. We're going to use theta. It always means the angle. So we put the number 3. That represents the opposite side over the hypotenuse. The hypotenuse is always the same. Okay? It's always opposite of the right angle. Okay? Yeah. So sine theta equals 3 over 5. That's just the ratio. We're not going to solve anything yet. I just want to work on building them.
Yeah, that's what Sarah said today. He didn't really work on solving them.
Okay.
He did, like, he showed us how to, but this is more.
Yeah, and let's do this. So let's talk about that same theta. So exact same angle, exact same triangle. Measurements, so if you look, our measurements are the exact same as this one. But instead of building the sine ratio is when you kind of have a fraction that's equal to something else, or 2 numbers that have some kind of relationship. Cos theta, this is a same triangle but a different ratio, is going to be equal to the adjacent. Which side is adjacent to this theta? Adjacent means to be touching, okay? And there's technically 2 sides touching it, but one of them is already spoken for, right?
Yeah, which is the 4 side, right? The one with the 4 in it?
Well, let's do this first. What do you think 4 is? Do you think that's the adjacent or the hypotenuse?
Hypotenuse.
Okay. What did we say about the hypotenuse? It's always what?
Oh, across. Yeah.
So we know that because it's divided by the hypotenuse, that means that the side that's touching but not the hypotenuse is 4. So cosine is equal to 4 over 5. And remember, this is where it's written, adjacent divided by hypotenuse. We did 4 divided by 5. We have those same ideas. Maybe I should keep those up top.
Adjacent is...
The side touching it, that's not the hypotenuse. Okay? We'll go over that again.
Yeah.
Because we'll do another
You
example.
could, like, label the name on this side.
Yeah, and here I'll write this. This is the ADJ. That's the adjacent side, and this is the HYP. Hypotenuse, this was the HYP. Okay? So we've done it twice. This side 5 must be the hypotenuse,
So
right?
This is the HIP, this is the
This was the opposite.
opposite. Okay.
All right.
Yeah.
Now, TOA, tan ratio. Tan theta is equal to opposite. So which one's opposite?
So
Oh,
from
and that's
the
supposed
theta,
to be in
right?
red.
Oh.
Yep. That's opposite. I'm going to change those colors. And the adjacent's supposed to be,
Blue.
yeah, and which one is the adjacent?
The adjacent is. The adjacent's 4?
Number 4. Great. So that means it's 4, sorry,
Oh, because
opposite.
that's the hypotenuse. So
That's
the
right.
one left over has to be the adjacent.
Exactly.
Okay.
3 over 4. Okay? So there's our 3 ratios for this triangle. When we're talking about this angle, I'm going to speed through the next part a little quicker. Same stuff, same triangle. I'm going to write the exact same numbers. Okay, 5, 3, 4, 5, 4, 3. So exact same triangles, 3 different ways. But this time what we're going to do, okay, remember this is the right angle. So which one's the hypotenuse in every single one of these? What number?
The 5.
Yeah. So we know that's going to be hypotenuse. So I'm going to point it at green, right? It's always going to be the hypotenuse. In sine, this time we're looking for theta, but this time theta is going to be in this corner. And I want to show you what happens.
Does that make it negative?
It doesn't, but it changes our ratio. So sine theta. So this is remember up here we looked at this angle. Now we're looking at this angle. What's opposite of this theta here? Which side?
That side.
Yeah, the 4.
4.
So now our sine theta is equal to 4 over 5. And I want to draw your attention to this. We're going to do a little comparison.
So is this the SOA part of it? The SOA?
Yeah, this is just setting up the sine ratio. Okay? If you looked above, maybe I should zoom out just a little. Okay. When we talked about this angle, opposite was 3, hypotenuse was 5. When we talked about this angle, opposite was 4, hypotenuse was 5. So it changed the ratio. Depending on the angle that we're measuring, the ratios change. So we always have to have a reference point at that angle. Okay? And I'm going to build the next 2 really quickly using that idea.
So depending on the change, how does it?
Yeah, depending on which angle we're trying to find or which angle we have information about. So if this is theta again, that means my adjacent is actually the number 3.
How do you know in which case it switches? Because up there the triangles all look the same. So
Mhm.
how do you know to use
It
that?
depends what the question's asking us. So if the question is asking us for this angle, then we measure from this angle.
Well, it'll
If
tell
it-
you, like, measure from that angle.
Or maybe they'll give you this angle. And because you've been
of the
given this
number,
angle,
right?
yeah, you measure everything from it.
What number is that angle? 'Cause it's
Well, we don't know
saying-
yet,
Oh.
right? So, and I could have given us some numbers, right? I think we probably could have fit 30. We could have put this as 60 and this is 30. But for now, I
Oh,
just wanted
yeah,
to
right
name
now.
it something, right?
Oh, okay.
Okay, so that those numbers would normally
in
be
the
there.
question, if it said angle 60 and there's 60, then you know to do
Exactly.
that. Oh, okay.
Yeah, so I'm going to finish
Oh,
off the
sorry.
last 2. That's okay. So now, our adjacent is the number 3, and we're over the number 5. So it's a little different from above. And then again with tan theta is equal to, well, because this is our theta, our opposite happens to be the number 4, and our adjacent happens to be the number 3. So 4 divided by 3. So let's kind of zoom out here. So we didn't do any solving of anything. All we did was label our triangles, which is really important because in order to do any of the work with this, we have to be able to label properly.
Yeah.
Okay? Once we have that down, then we can start working on solving for unknowns. And these are 3 variables. These are the 3 variables. It's either the angle is the variable, the opposite side, the hypotenuse. Or it's the adjacent, the hypotenuse, or the angle, or it's the angle, the opposite, and the adjacent are